Okay, example 3 asks us to find the magnitude and direction of vector v, find the unit vector in the direction of v. Okay, magnitude and direction is a fancy way of saying polar form. Alright, so the polar form structure, the technique is what it was in Algebra 2, which is find the magnitude, find the reference angle based on quadrant, find the actual angle. Alright, so if we look at vector v, if I were just to, real quick, start off with its position, negative 4, 2 puts me over here somewhere, right? That's what negative 4, 2 looks like. Puts me squarely in quadrant 2. That's the only reason a minus sign is important in this process. Which quadrant are you in? Alright? And other than that, minus signs don't matter. So, the magnitude of v, I'm using the notation they like to use in this book, the magnitude of v, the powerful absolute value bars, is just going to be the square root of 4 squared plus 2 squared, which is the square root of 20, about 4.47. Unless they specifically ask for an exact answer, I'm going to go decimals on these. So 4.47. The reference angle alpha, going back to, again, Algebra 2, is an inverse tangent of the absolute value of the vertical over the horizontal. Right, vertical over horizontal, absolute value bars make things positive. So I had inverse tangent 1/2 or 2/4, take your pick. I am in degrees, so inverse tangent of 2/4 is 26.57 degrees. And step 3, depending on quadrant, in quadrant 2, the rule for theta is 180 minus alpha. So 180 minus that's going to be 153.43 degrees. So the magnitude and direction is going to be a 4.47 magnitude at an angle of 153.43 degrees. So as far as this request, that's it. That's the answer. The other request asks for the unit vector in the direction of v. A unit vector is a vector that's 1 unit long. Alright? So if I'm in polar world, here's how I make a unit vector. Okay, the number out here is the length of the vector, right? So I want a vector that's 1 unit long, I make the length 1, I just made a unit vector. And usually we call unit vectors u. Oops, I was hoping just to cut the circle out. Unit vector equals there. Alright. So this is v here, right? Vector v is this in polar form. Alright, vector u is the unit vector in the same direction as v. When they ask for unit vectors, they don't want the polar form, they want the rectangular form. So here's how to do it. 2 ways. Way number 1. 1 cosine, 1 sine get you the components. Alright? So if I just do the cosine of 153.143, 1 times that's the same as just that, right? And the sine of 153.143, 153.43, that gets me the component. So u is going to be in component form negative 0.89 comma positive 0.45. If I just wanted to go directly from this into this, in other words, they didn't ask me for the magnitude and direction, they asked me just for the unit vector, and I wanted to have a direct route to go from here to here without having to go through the middleman of this thing, which, not that that's terribly difficult to do, but it's stuff to do, right? You do have to do this step here, but all the unit vector is this vector divided by that number. Because that's all that's happening here is we're dividing the magnitude by this to create 1, right?
Yeah.
So if we divide the vector by 4.47, we'll get these 2 numbers. And if you try it out, negative 4 divided by 4.47 comes out to negative 0.89. And what was the other 2?
Yes.
Was it positive 2?
Yeah, it's positive.
Yeah. Alright, 2 divided by 4.47 should be 0.45. It is, okay. So, again, there's a way to get directly there. Again, you have to do that 1 step, and You don't have to do all the inverse tangent and stuff like that. So again, depending on what they're asking for. If they're asking for magnitude and direction, they want the polar form. If they want the unit vector, they usually want the unit vector in the component form. But if you've already got polar form, really easy to make the polar one, right? Change it to 1. And then cosine of that, sine of that gets you the unit vector in regular form.